Alright, starting the second video, starting with number 5 in homework 2.5. Okay, so for number 5 here, notice we're given segments, so we probably want to be looking at our segments proof reference. And again, we want to start by reviewing what these different terms mean up here. So we've got segment addition postulate, which remember allows us to add up portions of a segment and setting it equal to the length of the whole segment. So measure of AB plus measure of BC equals measure of AC. Transitive property, that was the one that we used in the previous one as well. Transitive property allows us to take, say, if A equals B and B equals C, then A equals C. Kind of like double substitution. And then the definition of congruence, that allows us to work between equal signs and congruence, or congruence to equal signs. Substitution property, remember the substitution property allows us to say if something equals something else, if A equals B, then A may be replaced by B in any expression or equation. And then the last one, given, we know given, and then definition of congruence, then we've already gone over that one. So it looks like we used that one twice in this video. So, the first reason is always given. So, if we look at this right here, the reason why we're able to make this statement is because it is given to us in the problem. So, let's look through the givens real quick. So, xy is congruent to uv. So xy is congruent to uv, and then yz is congruent to tu. So if those are congruent, and we want to prove that xz, the whole thing, is congruent to tv, the bottom whole thing. So that's our goal. So the first statement, the reason why we're able to say that is because it was given. So given for the first statement. Okay, then we look at this second part. What happened, what changed from number 1 to number 2? What seemed to happen? So notice how we still have xy, but it changed from congruence to equations. We went from a congruent sign to an equal sign for both of these. And if you recall, which one of these 6 up here allows us to move from a congruent sign to an equal sign? And that is the definition of congruence. So cross out that one and write definition of congruence for number 2. Number 2, definition of congruence. Alright, so number 3. So what allows us to go from number 2 to number 3? So it's really important to see what's happened. Now, did we use number 2 to make number 3? Or did we use something else? So if we look at this first equation and compare it to this equation, xy is in both, but uv is not in either one. This doesn't seem like we used these equations from number 2 to make number 3. So there must be some other thing that we used. So xy plus yz equals xz. Where do we see a picture or something that helps us with this? Well, notice up here, xy plus yz equals xz. So, any ideas of what this could be? Well, it's actually the segment addition postulate. Because remember, a segment addition postulate, it allows us to break up, say, the portion of a certain segment, the sum of them. So part plus part equals whole. Part plus part equals whole. And this second part, this second equation, comes from the bottom one. Tu, first part, plus uv, second part, equals tv, which is the whole thing. Part plus part equals whole. So number 3, the reason why we were able to make that statement was segment addition postulate. So go ahead and cross off that one or check it off. So from number 3. So now to number 4. This is where it tends to maybe get a little tricky. So it looks like these kind of look similar. Let's look at this first equation And let's analyze what's changed and what stays the same. So on the left side of the equation, right here to right here, what stayed the same? Well, we still have a yz and a yz, but xy transformed into uv. Then on the right side of the equation, xz stayed xz. So the only thing in this first equation that changed as we went to this second equation was xy became uv. Well, let's think about what could possibly allow that to happen. Let's look further up. xy equals uv. So what happened was, since xy equaled uv, we replaced xy in this equation with uv to turn it into this equation. And what likely happened with this second equation is something very similar. So notice. So remember, with this first equation, we think it'd be substitution property. The substitution property, substitution, is what allows you to replace something that equals something else in an equation. So let's confirm that this was substitution. So we got tu plus uv equals tv. Then we have yz plus uv equals tv. So the only thing that changed was tu goes into yz. And we have this statement right here. So yes, they substituted in yz for tu, creating this new equation from this one. So for number 4 is substitution property. So now, xz equals tv. And remember, we want to keep in mind what different options we have up here. We use segment addition, we use definition congruence, we used given, and we use substitution. All that we have left is transitive and definition of congruence. So when we go from 4 to 5, notice there's xz equals tv. xz is right there, tv is right there, and both of those are equal to the same thing. When when xz equals something and tv equals that same something, what allows you to conclude that xz equals tv is called the transitive property. Transitive property for number 5. Transitive property. And then number 6, the only thing we have left is definition of congruence, but of course, something that allows you to go from an equal sign to a congruent symbol is the definition of congruence. And that is number 5. All right, let's go ahead and do number 6 as well. So for number 6, definition of congruence. All right, so we have all of these. We've talked about all of these earlier in this video, so we don't need to talk about them again. But keep in mind, these are the things that we're using as the reasons for all of these statements. So the first statement is always given. The first statement is always given. So notice wy equals yz and xy equals vy. Technically that's a mistake. It should have said wy and it should have said yw instead of wy right here. That was just a mistake. So that should be YW. So the first statement here, the first reason that we were able to say this is because it was given to us. Okay? And we were trying to prove that since YW equals YZ and XY is congruent to VY, we're trying to prove that the whole thing here from X to Z is congruent to the whole thing there from V to W. So, first reason was given. So, first reason for number 6 was given. Alright, so, next. What happened from number 1 to number 2? Well, we look at each one, and notice how this one kind of corresponds with that one, and this one corresponds with the one with XY and VY. So, what happened to segment WY is congruent to segment YZ as we went to number 2? Well, the congruent sign turned into a symbol, and these changed into measures rather than the segments themselves. So what allows us to do that? If you don't remember, it is the definition of congruence that allows us to move back and forth between congruent symbols and equals, or equals to congruent symbols. So number 2 should be the definition of congruence. All right, number 3. So we have xy plus yz equals xz. That doesn't seem like it came from somewhere up here, unless we added something or something like that, but let's, xy plus yz equals xz. Where could that possibly come from? Well, looking at these and looking at our picture, xy plus yz equals xz. That is the segment addition postulate. So that's what allows us to say number 3, segment addition postulate. Okay, for number 4, vy plus yw equals xz. So we knew that this was the segment addition postulate. Vy plus yw equals xz. That's not the segment addition postulate. If this had been a VW, then that would have been segment addition postulate. Maybe. So the xz stayed the same as we went from 3 to 4. So notice how we have a yz right here that turned into yw. Notice how yz, and we have yw right there. What looks like happened was we substitute in for yz with wy, making it yw. That should have been a wy. And then we have xy that turned into vy. So we substituted to create this equation. So we substituted in for xy with vy and substituted for yz with wy to create this equation number 4. So this should be substitution property for number 4. All right, number 5. So remember, when two different things, all right, so vy equals yw, vy plus yw equals vw. That's another segment addition postulate, because notice how vy plus yw equals vw. So that's number 5, segment addition postulate. Segment addition postulate. And then xz equals vw. So xz equals vw. Where could those have come from? Well, we have an xz and a vw right there, and they both equal the same thing. When two different things are equal to something that's the same, then what allows us to say that those two things are equal to each other is the transitive property. Transitive property. So number 6 is the transitive property. Transitive property. So number 6 should be transitive property. And the last thing from number 6 to number 7, when we go from an equal sign back to a congruent symbol, is the definition of congruence. So that's what brings us to the end of number 6.